In this section, we will learn about the Yavadunam method or the deficit method in Vedic mathematics. This method is used to find out squares of numbers, and it can also be used to find out cubes of the numbers. Let's use this method to find out squares of numbers which are near and less than 10 to the power n. For examples, numbers like 9, which is near to 10, 96, which is near to 100, 994, which is near to 1000. Let's multiply 9 into 9, or the square of 9. So how this method works is, the answer again comes in two parts, RHS and the LHS. First we'll find out the deficit of number from the base. So 9 has a base 10, so the deficit is 1, since 10 minus 9 is equals to 1. So the RHS part would be the square of the deficit, so this becomes 1 square, and the LHS part will be the number minus the deficit. So our answer comes as 81. Let's just go through this once again. What we'll do is we'll find out the answer in two parts, LHS and RHS. The RHS part would be the square of the deficit from the base, and the LHS part would be number minus the deficit. Let's take one more example, 96 square. So here the deficit is 4, so the RHS part would be 4 square, and the LHS part would be 96 minus 4. So this becomes 9216. This is our answer. Let's see one more example. Let's multiply 994 square. So 994 is 6 away from the base, so the RHS part would be 6 square, and the LHS part would be 994 minus 6. So this becomes 988036. Notice we have taken 3 digits here in the RHS because the base is 1000, so the RHS part would be in 3 digits. Now let's try to prove how this method is working. So any number n which is near to a base can be written as x minus y. For example, we can write 9 as 10 minus 1, where 10 is the base and 1 is the deficit. So x minus y square is equals to x square minus 2xy plus y square, which becomes x into x minus 2y plus y square, which again can be written as x into x minus y plus y square. So if you notice, this x minus y is our number, so this becomes x into n minus y plus y square. So if you notice, this x is the base, so this becomes our left hand side part, and this y square becomes our right hand side part. So that is n minus y in the left hand side and y square in the right hand side. Now let's use the same method to find out the squares of numbers which are near to the bases like 10, but they are more than that. For example, let's take 13 square. So the only difference which is there is, this time we don't have a deficit from 10, this time we have a surplus from 10. So what we'll do is, again the surplus from 10 is 3, so the RHS part would be surplus square, and the LHS part this time would be the number which is 13 plus the surplus. In the previous method we were doing the number minus deficit, this time we'll do number plus surplus. So this becomes 16, and 3 square is 9, so this is 169. Let's take another example. Let's multiply 103 square. So the deficit is 3, sorry, the surplus is 3, so the RHS part is 3 square, and the LHS part is 103 plus 3. So this becomes 106, and this is 09 since the base is 100. So the answer is 10609. Now let's quickly prove this method also. So there we were writing a number as x minus y, but here we'll write the number as x plus y, since number is more than the base. So this becomes x square plus 2xy plus y square, which is x into x plus 2y plus y square, which is x into x plus y plus y plus y square. Now you notice this is the number, this is the deficit, so we can write this as number plus y in the LHS and y square in the RHS, hence proved. Let's use this method to find out squares of numbers which are near to any basis. For example, a number like 388. 388 is near to base 400, so which is 4 into 100. The method is similar. First we'll find out the deficit. So deficit here is 12, since 400 minus 388 is 12. So the RHS part would be deficit square or 12 square, and the LHS part would be 400 minus 388. Sorry, the LHS part would be 388 minus 12. So this is 376 in LHS and 144 in RHS. Now since the base is 400, we only have 2 digits in RHS, so we'll have to carry forward this 1 towards LHS, but before that we'll have to multiply 376 with 4, since we have taken base as 4 into 100. So this becomes 1504 in the LHS and 144 in the RHS. This one will be carry forwarded, so the answer is 150544. Let's take one more example. Let's find out 485 square. So we'll take base as 5 into 100 or 500. Deficit is 15 here, so RHS is 15 square and LHS is 485 minus 15. So this is 470 in the LHS and 225 in the RHS. Now here again this 2 will be carry forwarded here because the base is 500, and thus we can only have 2 digits in the RHS, and this 470 has to be multiplied by 5 because the base is 5 into 100. So this becomes 2350 in the LHS and 225 in the RHS. We'll carry forward the 2 towards LHS, so our answer comes as 235225.